kids. I hope you've really enjoyed getting into Chapter 9 last week. We know that we've moved into Unit 3, which is Earth and Space Science. And so one thing that you've been studying is the Earth and its structure. So let me just go back and remind you of a couple of things about our Earth, its structure, and the key ideas that I really hope that you grasped last week in your studies. So right now I'm just doing a quick review. We're open to page 102 and 103. I do want you to have your science book there. That way you can look at your book page if you need to put me on pause for a minute and go grab your book. We'll be looking at the beginning, 102 and 103. So real quick, while you're getting your book, let me just show you the structure of the Earth. We've learned that there are some main parts of our Earth, and we start right here in the inner core, and then outside of that is the outer core. I have another example for you right here, and the inner core is extremely hot. It has the highest temperature, but it's a solid mass. And the outer core is also really, really hot, but it's got a liquid mass. And so the inner and outer core are two different components there. Then we get into the mantle, and the mantle is the next section here. So this would be your lower mantle closer to the core, and this would be your upper mantle closer to the crust. The crust is the outside, what we walk upon every day, what you're familiar with seeing. And so our new word that you probably learned last week is lithosphere. The lithosphere includes both the crust and the upper mantle. And so working together, there's some things that are happening and the way God designed our Earth because of the layers. So one key idea I wanted you to grab from last week is that our Earth is always changing. It's always moving. There's never anything that stays very settled. And part of that is because of our second big idea. And our second idea is that the Earth is made of layers. So just like this onion, if you were looking at your book page 103, you notice the picture of the onion. These are strata layers. You can definitely see layers. There's another place you might see a grand assortment of layers. Do you know where that might be? That would be the Grand Canyon, wouldn't it? So if you've seen pictures or gone there, you've seen a great big canyon full of strata layers and lots of different colors because there's a lot of different sediments happening and layering upon each other. So God intended for our Earth to be made a certain way. And right now what I thought I would do is talk more about the shifting and the moving and the changing. If your book is open to page 105, you'll probably notice the picture of the landslide. I won't turn there, I think you can see it. The landslide picture shows that there's a whole bunch of Earth up here, but something is happening down at the base, and it's probably moving and shifting, which is causing this Earth up here to become unstable, and then obviously slide down the land. So how many of you did the experiment with the graham crackers and the pudding? I'll tell you, I left my pudding at the school, and so today I'm improvising and using applesauce. It'll do the same thing. So here, let me show you real quick. If you did not have a chance to do this one, we're going to talk about tectonic plates. And the purpose of the graham cracker is to show how the tectonic plates in our Earth move and shift. Now, the tectonic plates are in every single body of land on every single one of our 7 continents. And it's more up here where the crust, the outer crust is, and it can shift and change. So there's different directions it can move. So one way that plates of land or tectonic plates can move is back and forth, can go against each other. There might actually be 4 ways because another way is up and down. It can move away from each other, and it can move toward each other. So with my little applesauce pile here, we're just gonna look at a couple of things that happen real quick. Many of you tried this with pudding, and I think it actually works better, but if your tectonic plates are land, the pudding or the applesauce would be the magma or the loose and hot ground. Maybe it's not stabilized and formed yet, so it's able to move a little. If you have land that's moving back and forth, it's because it's on softer, hot areas. So it can move back and forth. It can also move up and down like this if it were on 2 levels of under Earth there. And it can also push against each other, toward each other. And when that happens, everything in the middle kind of starts caving upward. And what do you think could be forming from that? It would be mountains. And you might get a few rolling hills. You might get some big, tall mountains out of it. But that's where land shifts and actually pushes against each other this way and causes more mountains. Now, if the plates, the tectonic plates, move apart from each other, then there's more magma and heated area to either become solid and become other things, or to become volcanoes. If it stays active with heat and the magma stays active, usually volcanoes happen and are formed during this time. So the tectonic plate movement is something that we're always studying, because anything that's happening down on our undersoil causes something to happen above. That's where we have earthquakes and other catastrophes that we need to look at. So last week you also read probably about sorry about that, our vocabulary words. Let me see what you can remember real quick, and then I'll move forward and we'll talk about a couple of more things that I have here for you. We'll get this one ready to go. All right, how about these words? Inner core, outer core, mantle, crust, lithosphere, magma, faults, a fault line, which we just described. A fault line is that line of Earth that it's faulty and it's causing some movement. And tectonic plates. Now there's one more that I wanted to mention real quick, and that is convection currents. How many of you remember reading about the convection currents, where the magma from down in the inner and center cores here, it's very hot, it's bubbling up, it's wanting to rise to the surface because heat rises. And so if you saw an experiment about hot and cold water, what you would notice is that things that are hot, like a hot liquid, when they're joined with a cold liquid, always rise to the top, and the cold liquid will always sink to the bottom. Now, there's a way that you can tell the difference by adding food coloring. I did not heat this today because of time, but I just wanted you to know that if you're really looking to watch it happen, you would add food coloring. You would pour the hot into the cold, and you'd let it settle for a little bit. And personally, I put a white piece of paper behind it, or I couldn't quite see the layers, but you'll notice the clear cold water will stay at the bottom, where the colored food coloring water rose to the top because it's hot. So what that's doing is it's a convection current. The hotter magma is wanting to come up, but then it cools down. And so as it comes back up this way, it cools down and goes back down, because cool things go down. And so it's a current. It's an always happening movement. The hotter magma wants to come up and the cooled magma wants to come back down. And that's what those convection currents do. So when we meet next time, I'm going to be giving you the next part of chapter 9, and we'll learn a few more new things together, and we're going to actually look at some more things that I have in front for you today. So look for the next video. I appreciate it.